Hello. In this video, we're going to be talking about circles. We're going to hit a completing the square review. We're going to graph circles given their standard form and converting from general to standard form using that completing the square. So let's get to it. All right, let's start with a review of completing the square. Here I've listed all the steps in case you've forgotten them, but let's just work through this problem. First thing I want to do is separate my variables from my constants. Next I want to divide by a. That's a super important step that a lot of people leave out on accident, but in order for completing the square to work, this needs to be a 1x squared. Now the next step is to complete the square by adding b over 2 squared to each side. So I'm going to add negative 3 over 2 squared to each side. What's important to notice here is that this is still 5 times this, so whenever I add this to the other side, I'm actually adding 5 times negative 3 over 2 squared. All right, so here I've cleaned it up a little bit just by changing my negative 3 over 2 squareds to 9/4. So here I can actually add these, and I'm going to factor this. Whenever you factor this portion, it's always just this number that's going to show up. And what I mean by that is visible here. Like the two numbers that multiply to 9/4 and add to negative 3 are negative 3 over 2. So this factors down to x minus 3/2 squared. And then this just came together to be 61/4. And finally, as our last step, we'll actually just put everything back on this one side of the equation. All right, and that's completing the square. So let's get to circles. All right, so the definition of a circle is the set of points that are equidistant, just a radius, to a fixed point, the center. Standard form is x minus h squared plus y minus k squared equals r squared. And this has a center at h and k and a radius equal to r. And so let's graph x minus 2 squared plus y plus 3 squared equals 9. So keeping the standard form in mind, we can see that this has a center at 2, negative 3, and a radius equal to 3, since this is r squared. So let's graph that. All right, so this circle has a center at 2, negative 3, and from there I can just go up and down 3 in each direction because that's my radius, connect them, and now I've got my circle. And there you have it, we graphed a circle. Okay, now the general form, and we're going to see this for all of the conic sections, is ax squared plus by squared plus cx plus dy plus z equals 0. But for circles, a is equal to b. Okay, they have the same sign and they're the same number. And to graph these things, we have to complete the square so we can put them in standard form. And you have to complete the square for x and for y. All right, so let's do that for this problem right here. 3x squared minus 6x plus 3y squared plus 4y minus 4 equals 0. All right, very first step is get the 4 on the other side since that's my only constant. The next step is factor out those leading coefficients of x squared and y squared. All right, so next we're going to complete the square by adding half that middle term squared. So half of negative 2 is negative 1 squared. Half of 4/3 is 2/3 squared. And then remember that we have to multiply by these coefficients outside as well, so we're actually going to add 3 times. Negative 1 squared is 1, and 3 times 2/3 squared is 4/9. All right, next we'll factor, so 3 times x minus 1 squared plus 3 times y plus 2/3 squared equals, add up all these things, and that's 25/3. Again, a real easy way to factor these is it's always half of this middle term is going to go right there. Now, to get this in true standard form, I need these 3's to go away as well. So I'm going to divide both sides by 3. And that lets me end up with x minus 1 squared plus y plus 2/3 squared equals 25/9. This will have a center at 1, negative 2/3. And because r squared is equal to 25/9, r is equal to 5/3. So this is centered at 1, negative 2/3 and has a radius of 5/3. That's changing from general form to the standard form of a circle. All right, and that's everything. Goodbye.